Hello, chemistry class. It's Mr. Ng with some sample Stoich problems. I'm hoping this will get you through your packet. Let's start with question number 5, which gives us a balanced equation. That's cool. The balanced equation is going to be used right here in this middle step. Right, here's a little mnemonic, a little map to guide us through this problem. And let's get through this. What mass of iron, Fe, is needed to react with 16 grams of sulfur, and this is sulfur S8. So this is our given. That's pretty easy. I think all of us know how to do that. So our given is 16 grams of S8. Notice that for our given, we have a couple of components. We have the value, we have a unit, and we have a chemical. Make sure that you have all three of those components, just because it's hard to do Stoich without them. So here, if you notice, we started out with a mass, right? So we're right here. We're at mass A, and we want to change it to a different chemical. In order to change it to a different chemical, we have to go through moles. I know it would be really convenient to just use the mass ratios and go from mass A to mass B, but we really can't do that directly, at least not with the math that we know now. So instead, it's way better for us to go through moles, right? So here, this step, we can't do this, right? So let's go through moles. So here, to get to moles, we need to get out of grams. So if you remember dimensional analysis, grams goes on the bottom, grams of S8, into moles of S8. And if you recall, when we go between grams and moles, we're going to use the periodic table. We're going to find the molar mass of S8. So 1 mole of S8, well, let's do that real fast. 1 sulfur is 32 grams, so it's just 32.06 times 8 is going to be the mass of S8, right? We just want to have the mass of all 8 of those suckers. If you do the math, you'll find that it's 256.48 grams of S8. Good. So this is going to cancel. We're going to get out of grams of S8, and now we're in moles of S8. So here, we're now right here. We're at moles of S8, and we want to change the chemical. We want to move on over to the different chemical. And for that, we're going to use our molar ratio. So we're going to go from moles of S8, and we want to go into moles of iron. A very common mistake that I see here is that some of you are trying to convert this from moles of S8 to grams of iron, but you got to go one step at a time. You use this little map, right? Or notice that you can only change one thing at a time, right? Here, we kept the chemical the same, so we could change the unit. Now we're going to keep the units the same. They're both in moles, and that'll allow us to change the chemical. Okay, so here, when it's a mole-mole ratio, if you remember, we're using the coefficients from the balanced equation. So it's 8 irons for every 1 S8. 8 moles of iron for every 1 mole of S8. Right, so here, that'll get us out of moles of S8. Now we're in moles of iron, but it wants the mass of iron. So right now we're here, we're at moles of iron, and we want to get to the final step, mass of iron. We're going to use the molar mass yet again. So here, to convert out of moles of iron, let's get out of moles of iron. And let's get into grams of iron right here. Grams of iron. This periodic table, this little snippet of it, says that 1 mole of iron weighs 55.845 grams. Good. So now we just kind of plug this into our calculator. 16 divided by 256.48 times 8 times 55.48, and I got 27.9 grams of iron. Good. So what did I do? Again, let's annotate this. First, I had a given. All right, that's just what I had, and the given had the value, the unit, and the chemical. And then I converted it to moles. I did this step using the molar mass. And we find the molar mass with the information from our periodic table. Great, right? And then the next step, we got from those moles, we could change the chemical. This is the word change, by the way. Change the chemical. And we changed the chemical by using the coefficients of the balanced equation. All right, this is the balanced equation. All right, this is the whole A plus B back and forth, C and D. We use the numbers in front, the little coefficients. Okay, that helps us change it into the chemical. And finally here, we rearranged it, we converted it back out of moles and into grams. So here we're using molar masses again. Okay, hope that helps. Let's do another one. Here is the second part of question 5 out of your packet. So how many grams of iron Fe, so we're in grams, or it wants grams, are reacted to form 16 grams of iron sulfide? So that's obviously our given. 16 grams of iron sulfide. So here we're again at a mass. This is where we're starting out. This is our given, right? So that means our first step is to go into moles. So let's get out of grams and into moles. Grams of iron sulfide to moles of iron sulfide. And the problem was very kind. It already gave us the molar mass. Hooray, hurrah. So it says that every 1 mole is 87.91 grams. And sometimes some of us write the 87.91 on top, and that's not appropriate on this case. Sometimes the grams goes on the bottom, sometimes the grams goes on top. All you got to do is marry the grams with the molar mass, right? And then on the other side, it's 1 mole. So when we do a conversion between grams and moles, it's always 1 mole. Right? That's a pretty hard rule. When we're going from moles to moles, then you're going to be using the coefficients. But here, right, if you're wondering where to write the molar mass goes on the bottom because the grams is on the bottom. Stick with the rules of dimensional analysis. So here, that gets us out of grams of iron sulfide. Good. And now I'm in moles. So now I get to do this step, right? I'm now at number 2, right? 2, I need to go I'm right here, right? I'm right here, I'm at moles, and now I want to skip over to the moles of the other chemical. All right, to get to the moles of the other chemical, let's get out of moles of iron sulfide, and it wants us to get into moles of iron, so let's do moles of iron, and notice that in this step, we're going to use the chemical equation. So that means 8 irons, 8 irons for every 8 iron sulfide, though. Okay, so I'm going to multiply by 8 and divide by 8. So we're not going to change the value here, right? Notice that I'm using the coefficients of the balanced equation. Good. Now I just need to convert from moles of iron up to the mass of iron. And again, we're going to use the molar mass. So here, 1 mole of iron weighs right here 55.845 grams of iron. Good. So now all we got to do is punch it in. So I'm going to start with 16. I'm going to divide it by 87.91. And then I'm going to multiply it by 8, divide by 8, and then finally multiply it by 55.845. And I got 10.2 grams of iron. Thanks a lot for watching.